Today, the topic which we are going to discuss is phase rule. It is used to explain a heterogeneous equilibrium equation or reaction. As an example, let us consider this reaction, that is calcium carbonate, which gives calcium oxide and carbon dioxide. Such a equilibrium is said to be heterogeneous because the reactant, that is calcium carbonate, exists in solid phase. The product, one product, that is calcium oxide, exists in solid phase. Carbon dioxide, it exists in gaseous phase. So different phases are available. Therefore, this system, it is considered to be a heterogeneous system or equation. Such a equation or reaction usually it is not influenced by the factors like that of gravity, magnetism, and electrical forces, but it is all influenced by the factors like that of temperature, pressure, and concentration. To understand the number of factors which influence the heterogeneous equilibrium equation, and there is a rule called phase rule, which is written as F is equal to C minus P plus 2, where F is for stands for degrees of freedom, C stands for components, and P stands for phases. So these three terms, let us see what it is in detail. Coming for phase, it is the physically distinct, mechanically separable portion of a system which has definite boundary. That can be explained with the help of an example, that is mixture of oil and water. When oil and water are mixed, it becomes a heterogeneous mixture. The meaning is oil and water both are immiscible liquids and do not uniformly combine with each other, and when it is taken in a vessel, two different layers are seen, and a boundary, definite boundary is found between the two layers. If definite boundary is seen and if two layers are separated, then it is considered to be two phases. The number of phases are two. As another example, alcohol is taken, which is also a mixture of ethanol and water, and there both ethanol and water, it is miscible, they are miscible liquids, and therefore when it is mixed, different layers are not seen, no definite boundary is available, therefore total together it is considered to be one phase. And about components, it is defined as the smallest number of independently variable constituents by means of which the composition of each phase in an equilibrium can be expressed in the form of a chemical equation. And that also can be explained with the help of an example. Consider such an equilibrium where water exists in the form of solid, liquid, and vapor. It exists in all the three phases, and it is all in equilibrium, which means that all three phases coexist together. And this equilibrium has been governed by the factors like that of temperature, pressure, and concentration. Uh, Even though water exists in three phases, if we see the component present in each phase, that is in ice, the component is water. Here, in the liquid form also, the component is water, and vapor also it is water. So, specifically, when each phase is considered, the component, the composition, or the compound present is water. So, it is a one component system. As another example, the heterogeneous equilibrium, that is calcium carbonate, which gives calcium oxide and carbon dioxide, is taken, where the reactant calcium carbonate exists in solid phase, and the product calcium oxide exists in solid phase, and carbon dioxide exists in gaseous phase. In order to define this particular phase alone, we require the components, that is calcium oxide and carbon dioxide. If this component has to be phase has to be explained, then we require the need of this component, that is calcium carbonate and carbon dioxide. Likewise, to explain this phase carbon dioxide, we require the component calcium carbonate and calcium oxide. So therefore, to define each phase, we require the next two components. Therefore, such a equilibrium is called as heterogeneous equilibrium, and the number of component is two component. Totally, two components are required to define each phase present in this heterogeneous equilibrium. The third factor which is to be explained is degrees of freedom. It is defined as the number of, that is the minimum number of independent variable factors such as temperature, pressure and concentration, which must be specified in order to define the system completely. Usually while expressing or while explaining a system, two factors are considered, the prime two factors among the three, that is temperature, pressure and concentration. And for equilibrium like this is a one component equilibrium. For this, the major two factors considered are temperature and pressure. And among the two factors, certain situations, one factor has to be fixed and other can be varied. So the number of factors which must be fixed and the number of factors that can be varied denotes the degree of freedom. So using these three factors, that is phase, component and degrees of freedom, the equilibrium can be studied or analyzed.